Welcome, everyone, to another deep dive with us.
Yeah.
Today, we're tackling a pretty big question.
Oh, yeah.
Are we alone in the universe?
The big one.
It's a question that's fascinated people for, well, probably as long as we've been looking up at the stars.
Absolutely.
And to help us explore this, we're diving into Jamie Green's book, The Possibility of Life.
It's a great read.
It is, and it's not just about the science.
Right.
She also looks at how science fiction has grappled with this question over time.
Yeah, and it's really fascinating to see how those ideas have evolved along with our scientific understanding.
So I guess one of the first things we need to tackle is how our very definition of life has changed over the centuries.
Yeah, it's really shifted.
Like what people considered life a few hundred years ago is pretty different from what we think of today.
Oh, absolutely.
Green starts her book with this great scene from Star Trek.
Uh-huh.
And it got me thinking about, how we tend to picture aliens.
Right.
But then she goes on to talk about this idea of spontaneous generation.
Oh, yeah.
And how for a long time people actually believed that life just arose from non-living matter.
It makes sense in a way.
Like if you saw, maggots appearing on meat.
Yeah.
You might think, oh, there you go, proof.
Exactly. Or mushrooms popping up.
Yeah.
Seemingly out of nowhere.
Yeah, just like, bam, life.
And if that's how it works, then the universe must be teeming with life.
Right. It's everywhere.
Everywhere you look.
But then along came Darwin and Pasteur.
Yeah, that they really changed things.
And they kind of threw a wrench into that whole spontaneous generation idea.
They did.
So Darwin, with his theory of evolution, he showed that life wasn't static,
It has a history,
that it changes over time.
a process.
Right.
And then you've got Pasteur.
Yeah.
With his experiments, he proved that spontaneous generation wasn't actually a thing.
It wasn't just happening all the time.
No.
Like, poof, new life.
Life's origins suddenly became much more complex.
What's more special? So that must have kind of narrowed down the possibilities for life elsewhere.
It did, at least for a while.
For a while.
Yeah.
Because then in the 20th century, there was this idea that planets themselves were super rare.
Right?
So even if life did somehow arise on Earth, the chances of it happening on another planet
Seemed almost impossible.
astronomically small.
Yeah, the odds were stacked against it.
But then, and this is where it gets really exciting,
Things changed again.
the discovery of exoplanets in recent decades.
Dozens of them.
Thousands. I mean, suddenly planets are everywhere.
They're not so rare after all.
No.
So maybe life isn't either.
It's a game changer.
Completely revolutionized the search for life beyond Earth.
Yeah, I mean, it's incredible to think about how far we've come in our understanding of the universe.
It is.
But even with all these planets, we still haven't found definitive proof of life out there.
Not yet.
So how did it even begin here?
That is the question.
How did life begin on Earth?
The million-dollar question.
Green talks about Stanley Miller's experiment in the 1950s.
The primordial soup.
Yeah.
The famous primordial soup experiment.
Where he tried to recreate the conditions of early Earth in a lab.
Yeah, and he was actually able to create amino acids.
The building blocks of life.
You got it.
It's amazing. So he basically made life in a test tube.
Well, not quite.
Not quite.
It's more like he made the ingredients.
Okay.
The building blocks.
So it's not just about the ingredients.
No.
But the process, the recipe for life itself.
Exactly.
So I'm guessing there's no easy answer to that.
There isn't, unfortunately.
No single explanation for how life began.
It's one of the biggest mysteries in science.
Green highlights two main schools of thought.
Okay.
The RNA world hypothesis.
Yeah.
And the metabolism first approach.
Two very different ideas.
So RNA world proposes a stage where RNA...
A simpler molecule than DNA.
Right, played a key role in early life.
Essentially the precursor to DNA.
The OG genetic code.
You could say that.
But then there's the metabolism first approach.
Which focuses on energy flows.
Okay.
And the chemical reactions that could have given rise to life.
So it's not just about what life is made of.
Right.
But how it works.
How it uses energy to maintain itself.
To grow.
Yeah, the fundamental processes of life.
Okay, so two very different approaches.
Both trying to answer that same fundamental question.
Where did we come from?
How did it all begin?
And Green points out that trying to pinpoint a single origin event...
That happened billions of years ago.
Billions. It's mind-boggling.
It is a massive challenge.
So maybe we'll never have a definitive answer.
Maybe not.
But it's still fascinating to think about all the possibilities.
Absolutely. And it makes you appreciate just how complex and amazing life is.
And that's just here on Earth.
Right. Imagine what could be out there on other planets.
That's what we're going to delve into next.
Can't wait.
So stay tuned for part 2 of our deep dive, where we'll explore what alien life might actually look like.
And how we might even begin to recognize it.
It's going to be wild.
Oh, yeah.
So we've talked about how tough it is to even define alien life.
Yeah.
But let's say it's out there.
Okay.
Where do we even begin to look for it?
Well, Green has this really interesting approach in her book.
Okay.
She suggests we start by looking at Earth.
At Earth?
Yeah, but as if it were an exoplanet.
So like pretending we're aliens looking at Earth for the first time?
Exactly.
Yeah, that's kind of cool.
It helps us figure out what signs of life we should be looking for out there.
Okay, so what would give us away? Like, what makes Earth stand out as a living planet?
Well, for one thing, we have a pretty big moon for our size.
Right. Green talked about how that was probably caused by a huge impact early on.
A massive collision.
Yeah, and that it might have actually helped create the conditions for life.
It's pretty wild when you think about it.
It is. All this stuff had to happen just right for us to be here.
And the moon doesn't just have a cool backstory.
Right.
It also helps stabilize Earth's tilt.
Which gives us our seasons.
Without those regular seasons, who knows if complex life would have ever evolved?
So a big moon, stable tilt.
Those are good starting points.
What else?
Plate tectonics.
Ah, the Earth's crust is constantly moving around.
Yeah, and that might seem destructive, earthquakes and volcanoes.
Not exactly ideal for a picnic.
Haha, no. But it actually helps regulate our climate over long periods.
Really?
Yeah, it cycles carbon between the atmosphere and the planet's interior.
So it's like Earth's built-in thermostat.
Kind of. Keeps things from getting too hot or too cold.
Fascinating. But do we know if other planets have plate tectonics?
That's one of the big mysteries.
So it's not just about finding a planet with water and a nice temperature.
Nope. There are so many factors at play when it comes to habitability.
And Green uses science fiction to explore some of those factors.
Yeah, it's a great way to think outside the box.
She talks about this novel, Flood, by Stephen Baxter,
Oh, yeah.
where he imagines a planet called Earth 2,
But it's tidally locked to its star.
meaning one side always faces the sun.
Exactly.
It sounds pretty intense.
It creates some crazy extremes.
So half the planet is scorching hot, and the other half is frozen solid.
Basically.
Yeah.
Baxter describes it as this wild world with these narrow habitable zones.
I can't even imagine trying to survive on a planet like that.
It makes you realize just how diverse alien environments could be.
Yeah, way beyond anything we can probably even imagine.
Oh, absolutely.
And Baxter also wrote this other book, Python,
Oh, I love that one.
where he explores the idea of terraforming.
Transforming a planet to make it more Earth-like.
Right. And in this case, it's Saturn's moon, Titan.
But things don't go quite as planned.
No.
A runaway greenhouse effect.
Uh-oh.
It's a cautionary tale about messing with nature on a planetary scale.
Even with good intentions, we could really screw things up.
We have to be careful.
Okay, so we've got these crazy planets.
Yeah.
But what about the life on them?
Now that's where things get really fun.
Green uses all sorts of examples, both real and fictional.
Show us just how weird and wonderful alien life could be.
Like the anglerfish with its little glowing lure.
It's like something straight out of a horror movie.
Right, but it's a real creature.
Living in the depths of our oceans.
Then there's the duck-billed platypus.
Oh, the platypus.
That thing's just bizarre.
It's like evolution decided to play Mad Libs with animal parts.
But it works,
Somehow it all comes together.
which is kind of the point, right?
Yeah, what we
Yeah.
think of as normal is just based on our limited experience here on Earth.
There could be all sorts of crazy life forms out there.
Things we can't even begin to imagine.
And speaking of things we can't imagine,
Oh.
Green brings up the xenomorph from the movie Alien
Oh, yeah.
as an example of something truly
The
alien.
creature that breaks all the rules.
I mean, it's part insect, part reptile. It even has human-like qualities.
But it's all twisted and combined in this really unsettling way.
It's like a nightmare come to life.
It plays on our deepest fears of the unknown.
Yeah, it makes you wonder how we'd react to a truly alien intelligence.
That's a whole other level of weirdness.
And that's exactly where we're headed next.
Alien minds.
Can we even begin to comprehend what it would be like to think like an alien?
Stay tuned for part 3 of our deep dive where we'll try to wrap our heads around that very question.
All right, let's talk alien tech.
It's a pretty vast topic.
It is. I mean, where do we even start?
Well, Green lays out this framework called the Kardashev Scale,
Okay,
which categorizes civilizations by how much energy they use.
I think I've heard of that.
It's a way to measure technological advancement on a cosmic scale.
Doesn't it start with, like, harnessing all the energy of a planet,
Yep, that's a Type I civilization.
and then it goes up from there?
A Type II civilization can capture the energy of its star.
Wow.
In a Type III,
A Type 3 can harness the energy of an entire galaxy.
yeah, pretty mind-boggling stuff.
It is. It's hard to even wrap your head around it.
And that's where things like Dyson spheres come in.
Oh, yeah. Green mentioned those.
A Dyson sphere is a hypothetical megastructure built around a star to capture all of its energy.
So like a giant shell surrounding the sun.
Exactly. It's a pretty wild concept.
It is, but could something like that even exist?
Well, scientists are actually looking for evidence of Dyson spheres
Really? How?
by searching for subtle changes in the light emitted by stars.
So if something was blocking or absorbing a star's energy,
We might be able to detect it.
it's like trying to find a needle in a haystack.
It is a huge challenge.
But if we did find one,
It would be game over.
proof that we're not alone.
And that there are civilizations out there way more advanced than us.
That's both exciting and kind of scary.
Yeah, it raises all sorts of questions about what contact might be like.
Like, how would we even communicate with them?
That's the big question, isn't it?
Even if we could detect their signal.
Would we even understand them?
Green talks about some of the attempts we've made to reach out to ET.
Like the Arecibo message?
Yeah, and the Golden Record.
Those were pretty ambitious projects.
They were, but were they more for us or for them?
I think it's a bit of both.
Like a message in a bottle tossed out into the cosmic ocean.
A way of saying, hey, we're here.
But what if they don't speak our language?
Or what if their forms of communication are so different from ours?
That we don't even recognize them as messages.
That's a pretty unsettling thought.
It is, and Green doesn't shy away from the potential dangers of contact.
Right, she brings up the example of the Spanish conquistadors.
And the devastating impact they had on indigenous populations.
It's a reminder that first contact doesn't always go well.
Especially if there's a big power imbalance.
She uses science fiction to explore these kinds of scenarios,
Like in The Sparrow by Mary Doria Russell.
where a mission to an alien planet goes horribly wrong,
It's a cautionary tale about the assumptions we make.
and the potential consequences of contact.
Well, this deep dive has certainly given us a lot to think about.
It has.
From the origins of life to the possibility of alien civilizations with technology beyond our wildest dreams.
The universe is a pretty amazing place.
It is, and it seems like the more we learn.
The more we realize how much we don't know.
So where do we go from here?
I think we keep exploring, keep asking questions,
And keep our minds open to the possibilities.
because who knows what's out there waiting to be discovered.
Well, that's about all the time we have for today.
Thanks for joining us on this deep dive.
And until next time, keep looking up and keep wondering.